Welcome back. You're still watching Tech for Earth, and I'm honored to be having with me in the studio for tonight Dr. Wael Badawy, the Professor of Artificial Intelligence and Computer Engineering. Dr. Wael, thank you very much for being with us tonight on Nile TV International and Tech for Earth.
It's always a pleasure being with you.
The pleasure is all mine. Of course, today we will be focusing on the identity of the smart cities, because we've heard about it over the past 10 or 12 years under the tenure of President Abdel Fattah al-Sisi, with building and constructing more than 20 or 30 different smart cities, having a new capital, the new administrative capital. What is the smart city?
A smart city, in short, it's a city which understands what kind of resource can be managed or can be allowed. So there are so many examples. One good example that cities, when you have in the morning everybody coming in, you will find the road are switchable. So 3 lanes out of 4 lanes will be in, and at leaving time around 2 o'clock or 5 o'clock, it will switch. So switchable lane, this was the very first aspect of a smart city. We watched this in so many countries more than 20, 30 years ago. For us, smart city means that everything in the city is under control. You can sense it, you know what is it, so you can, for example, adjust heat by controlling the amount of natural gas injected. You can also know what kind of resources you need for plantation. For busing system, you will have sensor that where the bus station will be. So the whole city is connected. The city also will include some signages. So you'll find some directions about signages. So this is what we call it smart city. City which understand the population and the movement of population within the city premises.
Yes, you mentioned, Doctor, the importance of the management of resources. Does this mean that big cities, the capital like Cairo, for example, another city like Alexandria, they can never be smart?
They could be smart, however, you need to outfit the current infrastructure. So if you remember, when we talk about AI, we talk about Internet of Things or IoT. And the Internet of Things means a thing or a position where you can sense and you can control. So if we come to a city and we start to implement Internet, we start to implement Internet of Things, it will become smart. One good example is there are so many places where we see irrigation for plants. Yes. So you'll find the irrigation is running, the water will spill to the road, and maybe the plantation will never reach any water because someone switched the nozzle directions or something. So if you have sensor in this ground, it will say the ground is dry. It's now time for irrigation. You can for sure outfit the cities, the current cities, with infrastructure. However, it will be expensive because you will not build with internet in mind. So you have the barrier of buildings, the barrier of concrete. You will have also the routes themselves.
It will be more expensive to replace the infrastructure that we have nowadays.
Yeah, we call it outfit. We don't call it replace because it's not really a replacement. There is almost nothing there. However, right now we also see in different intersections you have a traffic light, and the traffic light will have timers. In a smart city, this timer will be adjusted to the amount of flow. As I was stating earlier, if you have a flow coming in, you will find a prolong, but the prolong will not be by time based, it will be based on occupancy based. So if the lanes will have lots of vehicles and the other intersection will not have vehicles, it will basically give the right of the way to these vehicles. And every time, remember, when you stand in a traffic light and see the crossing lane, don't have any passengers or any vehicles, and you are standing waiting for the timer, remember, this is not really smart city. It's basically organized as pre-timed. In a smart city, it will switch right away. It also gives priorities for emergency response, like fire trucks, ambulance, police cars. If they're coming across, you'll find the control of the intersections will give the priority for this kind of vehicles, emergency response vehicles. So these are all aspects of what we call smart city.
Dr. Wael, do we have cities here in Egypt that are being powered by the artificial intelligence nowadays?
We still have early, we can call it large compounds. However, it's not really large cities,
Yes.
except the new capital. The new capital, the different districts within it, it has lots of essence of AI and control. Because as we spoke before, like what's AI or artificial intelligence, is the computer can see, can hear, can sense, and will know what to do. So this is what we call it, like machine learning, voice recognition, computer vision. So there are lots of compounds and lots of new cities where they start to deploy this kind of sensors and start to control the HVAC or the heat and the air condition in buildings based on people in the buildings, and these are sort of smart cities. They call it smart building.
So there's no difference between the cities that could be empowered by the artificial intelligence and the traditional smart cities?
The traditional smarts, the only difference is the cities which is empowered by artificial intelligence or intelligent sensing points are built with the infrastructure in place. You have the wires, you have the cables, you have the wireless internet, you have the signages. In the other cities, the classical ones, you need to dig for installation, and this will be very costly. I believe it costs between 3 to 6 times or 7 times the cost of running a cable if you have everything paved and now you need to run a cable. So the other cities, they could. However, when we discuss this with the internet providers in Egypt, the city, when it's be smart, you build it with an internet for control and the internet for people to use.
Yes.
Alexandria and Cairo and the center of Cairo, we have only one internet.
For the people to use.
For the people to use.
Yes.
So we will segment part of this internet, and then we will be subject to cybersecurity attacks. We will be subject to other issues because now we are using the internet as mix between control, command and control, as well as for the public to use. So you may have lots of people in a school, for example, are using this for classrooms, and suddenly you cannot control because the bandwidths have been gone in this service. However, in smart cities, which we build city from the initial, or from the get-go, as they say, as a smart, it will have infrastructure only for command and control, and means that people cannot use it for the regular internet. And this is what will bring a high level of discussion around the security of this particular network, because nobody can log into this network. It's basically only the appliances or the equipment connected to this network. So this is the main difference. And when we discuss this with the main carriers, which is without naming them,
Yes.
one of the 4 big carriers in Egypt, and say, like, so why you cannot do this? They mentioned this as one of the biggest hurdles. So as we know, we build the system, all the IoT, all the sensing and all the control will be on an internet, and the people will be on different internet, and they call it bubble separation because they cannot they don't cross each other. So if you have an attack on people visiting websites or whatever, the other system is working. If we have high bandwidth on the people network, the other network is still having its own bandwidth. So this is the main differences, and this is why it's cheaper to build for smartness early on than outfit with a smartness.
You've also mentioned, Doctor, that the cities that are being empowered by the artificial intelligence, this means that they have computers that know what to do, what to fix, where to direct, where to go, what is the next step. But as you mentioned, there could be some errors, there could be some mistakes. Someone could try to hack into those systems. Who is really in control of the computer, which should be controlling everything within the city?
The IT support team will be overlooking this equipment. However, if you look at any of these designs, it will have what we call it fault safe, or when the system will have a fault, it will be safe. Exactly like when you have the elevator not working and you push the door of the elevator, it will open. So this is one of the things. Now, these systems nowadays are controlled. They also interface with humans, and they are not that critical. Like, there is a difference between critical mission systems, which basically you need to respond. But if you have the other systems and you wait for another minute or two, nobody will really care.
Yes.
So it's not as disaster as it sounds.
Like a power generator, a substitute.
A substitute, yeah. Yeah. So that's why this a kind of control it says it will enable us to prolong, for example, the maintenance, because now you know which roads have lots of vehicles, so you can go and maintain these roads more than the roads which don't have vehicles. We will so for fault diagnosing, we have equipment which makes sensing. It will sense if the road has a problem, if there is a high traffic, there is a long lines. All of this will be sensed by either sensors or cameras.
Speaking about the artificial intelligence, how, in your opinion, has it become more important every year going on to urban development in the world and in Egypt specifically?
It actually, I believe it's emerging in urban development because we can manage the resources and generate a more efficient, cost-efficient buildings and the platforms. So nowadays, between starting early on in smart homes by controlling blinds and controlling AC and heat, now you can have lots of other extras. So so it now become more embedded, and with the current prices for these units now, it become more accessible for even average price buildings. Is not high end because there are lots of volume requests. So that's why people are producing lots of component, and you know for a fact if the component will have large number, it will be cheaper and cost effective, or people can afford it. So I personally have been working with oil and gas exploration companies early on, and in their world there is no Google map. Because there is no roads. The roads are paved pathways, are not really paved roads, because they move the heads in the desert or in the or in the jungle, and it's only paved. Okay, there is no pavement. It's actually like just early primitive roads, and they don't exist on Google Map because there is no Google Map for them. So once we have this kind of information for them, they start to manage their resources, and when we start to see rain, for example, or snow falling, they will manage to increase the safety of people. So having roads managed in this way and having systems managed in this way is for the goodwill of human beings.
Speaking about the human beings, and you mentioned, Doctor, that the appliances, the way we will be running appliances for the future, or maybe nowadays even in Egypt, could it get less expensive every year? Because to be depending on artificial intelligence, to be having those smart cities and the cities empowered by the AI, this means that it will be getting more expensive, at least till it would be reaching a peak and then getting cheaper.
And then getting it cheaper. However, last week I was covering on a radio another topic, which basically the new electronics coming to the market in form of phones, mobile phones, are about, they may see 40% increase. And the reason for that is the suppliers don't have enough components. They don't have enough memory. So theoretically, yes, when you have lots of sensors and lots of control unit, which we call it IoT, available, and there is a high demand on them, they will produce them in a large volume. It will become too cheap, or very cheap, or cost effective. We don't use the word cheap, we call it cost effective.
Yes.
However, what we have been watching with the current tension around the world right now, and having the logistics routes have lots of issues, there is lots of forecasts that the electronics themselves will be more expensive because there is not enough logistics to bring components from different places. Even if you recall, for example, like maybe 15 years ago or so in Taiwan, when they had the earthquake, the manufacturer of memory have been out of business because basically the earthquake hit the fab, and it took them about maybe 3 to 5 years to rebuild the fab. So with all of this unstable conditions, we don't know about the prices. But theoretically, yes. Theoretically, it should come as more affordable compared to 5 years ago.
But this means that the developments in the Strait of Hormuz, the war in the Middle East between the US and Iran, could be making things more expensive even for the mobile phones, as you mentioned.
Yes, and the same for COVID. If you remember, during the COVID time, we had issues with the logistics. So we could not transport lots of goods other than medication. So any of these crises which take places around the world, it will impact or fluctuate the prices.
But at the beginning of the episode, Dr. Wael, you've mentioned the importance of artificial intelligence, the importance of having smart cities even for Cairo, for Alexandria, and outfitting those older cities, historic cities here in Egypt, especially for the benefit of the traffic congestions, to be easing the traffic congestions and to be making it easier to be going from point A to point B as soon as possible and as efficiently as possible. How would you assess the experience that we are having in this file for the past 10 years?
My experience was overseas, and I was part of the first deployment of cameras on roads in a specific city. And I'm not a road engineer myself. Yes. I'm a computer engineering background, working lots with cameras and AI and stuff like that. And they imported the technology from France. And when we applied the technology over the road, we proven that the capacity could reach 60% or more of vehicles have been transporting, because basically monitoring the road with cameras and know why these particular vehicles will make a turn or make a swing, or maybe there is an incident. They don't call them accident.
Yes.
They call them incident. There is a slow bottleneck. This will change the mind of controlling the whole network of traffic lights. So in these particular facilities or these particular cities, we have fiber network running to all traffic lights. We have cameras on almost all traffic lights and straight roads, and there are computing engine behind which will control the delay of each traffic light. And once you see a pattern of swing in the road or avoiding the road, they send personal inspection. They inspect if this road need to be patched or need to be fixed or what's the problem. And when there is an incident, or they don't call them accident for a reason, they will come and send ambulance. So we were basically, people were surprised in this city why the ambulance will show up and the police car will show up without anybody calling them. And this was 2002, as old as that time. So having this kind of sensing, it gives good information about how we can manage our resources. So there are lots of studies which demonstrate that having more information, you can increase the capacity by with the same amount of facilities. And this is the challenge for Cairo or Alexandria. Like I was coming to here in central Cairo, pick any street, Abdel Khalid Sarwat, or there are lots of buildings there. You cannot increase the flow. The only way to increase the flow by coordinating all these traffic lights based on the occupancy of the lanes, not based on timers. And this one simple example for the viewer to understand how smart city could be smart. And you can scale up on this particular example to any way. If you have people waiting for buses, you will send more buses. And you have to have a flexible system which will be alternate signages. Signage can change, is not just infrastructure and computers, but all the service can be managed in this way.
Does this mean that the artificial intelligence can be predicting the traffic jams in the future, can be predicting the incidents on the road, as you mentioned, Doctor?
It can right now. If you give a specific patterns of traffic and number of flow, it can within seconds or minutes predict if you don't open this, if you don't allow the green light for so long, you will start to have traffic jam and you start to have building in these queues. And you'll be surprised that queuing theory, which used for this particular prediction, are around us from 1950s or so. However,
70 years we have it.
However, is not fast enough, is not real time, because they didn't have good computers. But the
prototype?
No, the theory itself, the concept itself. Like if you move 50 vehicles from here to here, from point to a point, with an average speed of so long, with the average length and width of each vehicle, and you allow the different jam, the different pattern to join a specific bottleneck, at this point, it will have a bottleneck. So these concepts exist in books, exist in project management, exist in series.
Yes.
The computing and the artificial intelligence are using these concepts now as real time because you have the sensor. So, so this is where we can say, like, having automation in this way, it will maximize the usage of our physical limitation or our physical facility.
Yes, Dr. Wael Badawy, allow me to be going to another infograph for Tech for Earth for today, speaking about the importance of the artificial intelligence in the urban development and, of course, for empowering the cities all over the world, and more specifically for Egypt. Welcome back. You're still watching Tech for Earth, and I'm honored to be having with me in the studio for tonight Dr. Wael Badawy, the Professor of Artificial Intelligence and the Computer Engineering. Dr. Wael, we're speaking about the traffic jams, how the artificial intelligence can be helping in predicting traffic jams, and you mentioned that theories have been put ever since the 1950s that are being implemented nowadays, practiced nowadays globally and hopefully in Egypt, to be predicting the traffic jams, how to be evading those jams, and quite possibly even the incidents and the accidents on the road. On the other hand, one important aspect of cars on the road, the vehicles on the roads, is the fuel consumption. How can the artificial intelligence be helping the citizens globally and domestically to be more efficient, cost efficient, as you mentioned, in this field?
For sure, if vehicles will be waiting or moving to a slow speed it will consume more and more of fuel. So basically having what they call it signage system or a changeable signage system where you can route different vehicles in different pathways because they have more availability and they don't have contingency. This particular way, it will increase the efficiency of using the fuel. It will also reduce the carbon emission and the carbon footprint of these vehicles. So having such signages and sensor, and someone will decide that there is a heavy traffic on this particular link and move them or switch them to a different link, is this basically what Google Map will do for you. Sometimes it shows a red and green.
Yes.
Sometimes I write down on signages having like 20 minutes to this particular destination, 15 minutes to this particular destination.
Yes.
Use alternative route, accident on the road. All these notification systems enable the drivers to make best choice. Now, from city planner perspective and from emergency response perspective, once you have this information, you will send emergency response to clear the road, and also you can manage the roads around the vehicles. There was a good example of a specific city where you have almost an island, where you have the city core.
Yes.
And this island is connected by bridges and one tunnel. So what they did is they said, okay, you know what, between 6 o'clock in the morning till 9 o'clock, we will make all roads getting inside the island. Nobody's leaving, because majority of people
yes, are going
in.
Yes.
And they call them reversible lane. So they usually keep like 4 or 5 lanes and 1 lane only to get out. Then from 4 o'clock or 4:30 till like 6 or 7 o'clock
we
at
reverse
night,
it.
Reverse it.
Yes.
So suddenly you have to drive in the opposite. And this creates an interesting phenomena that humans beings are not used to drive in these wrong lanes.
Yes.
And when you live in these countries, you'll understand they respect to a high extent the rules. So it took about 3 to 5 years of silly advertisement on TV that these lanes are reversible, which means you have to accept to drive to speed. And they had lots of statistics about how much they save of fuel, how much they save of minutes, and what the travel time will be, and it was amazing studies. Also, they had tried to compensate with public transportation or the group transportation.
Yes.
And the group transportation have the same issues. You need to have a specific time for training, they call them training, because they basically put different trains in a specific time. So all of this management could not happen if you don't have what we call smart city, because you need to have data. Based on the data, you can ask the computer to optimize the flow, or human being who understand queuing theory can optimize the flow.
How much data can the modern city, can the artificial intelligence empowered city be producing, generating every day?
With the 5G technology, you talk about 1 million point every kilometer square. Because when we talk about 5G and 4G, when we talk about Egypt, in particularly smart cities, Egypt did not come to smart cities. Egypt enabled lots of enabling technology. So less than a year ago, we started with enabling the 5G network. And the 5G is the wireless network. If we understand the difference between 4G and 5G, 4G you have up to 100,000 per kilometer square. 5G you have up to 1 million sensing point and control every kilometer square. So if we take a very strange assumption that we will maximize the use of the network and we will use almost all bandwidth in the network, we can have 1 million point can emit a value every fraction of a second.
Yes.
That's it. So you can basically, if we afford the sensors and we afford the installation of the sensor and what have you, we can generate lots and lots and lots of data.
And how can this data be translated into useful decisions in the everyday life?
They use it in a different ways. One way is to filter the data to what you need, as like, for example, a changing trend, and then it will be streamed to data center, and in the data center it will be analyzing the data for a specific pattern. So when we have this kind of data, we always look for a pattern. We know what we are looking for. We know we are looking for traffic or jamming. So having this filtering of data, it's a very key into reducing the amount of bandwidth to send it back to data centers. So in Egypt also we have data centers, and we have there is a new contract of allowing a private data center. And the private data center, imagine the private condos and compounds in
Yes.
Egypt. They will use the private data centers. So the Egyptian government has a very an amazing vision to integrate all the infrastructure and produce the announcement and enable it on a specific time schedule. I don't know who did the schedule, however the schedule is currently is perfect.
And speaking of, as you mentioned, Doctor, the emissions, the carbon emissions, the carbon footprint, how can we be ensuring that the cities that we are building, the AI-empowered cities, the smart cities, the modern cities that we are seeing nowadays in Egypt and all over the world, will be more environmentally friendly?
We employ technologies which does not emit carbon. So, for example, we use electrical vehicles, and we use vehicles empowered by natural gas. This kind of vehicles have less footprint of CO2 compared to the standard vehicles who drive with gasoline. We also manage sensing point, because one of the biggest challenge, there are penalties for countries who have emission, and there are countries who claim they are not green enough, and countries which say we are green enough. So basically we can have sensor which will sense how much CO2 will be produced from this particular road and how much. We can also have sensors per vehicles, and you can, using the technologies we have, you can basically stop vehicles which emit more, which has a problem in the engine or what have you, so you can give it a warning so they can go and fix early on. So all this kind of management, you need sensors, you need smart cities, you need what we call it IoT, and there are lots of them right now available in Egypt.
But you also mentioned, Doctor, that we could be using more and more public transportation, and we need to be modernizing this concept. As you gave us an example from a foreign country and how they had the theory of reversing the roads for the people to be going in at a certain time and out of the city at another certain time. But what about the public transportation? What is the role of the artificial intelligence? How can the smart cities be entailing how smart the public transportation can be?
The first enemy for public transportation is not having enough passengers.
But we do.
That's right.
What we do here.
You don't have all the day.
Yeah.
You have it at early on and in the day when
the rush hours.
The rush hours. So when we have sensor to sense how long is the line in each traffic lights, traffic spot, we can actually direct buses and direct different transportation systems to be able to manage. We can even mobilize different kind of buses if we have different size of buses. So managing the public transportation with IoT means that I can pick up the right bus with the right capacity to go and get all of these people in. It's not just having a big bus and they have not enough passenger because you basically are 1 o'clock or 2 o'clock in the afternoon, maybe because you are 11 o'clock. This is maybe client coming, these particular services are not the actual people working there.
Yes.
So having this kind of estimation, now you can also schedule the buses so you don't move all the buses at once, so you can have a bottleneck or a deadlock somewhere. So all of this management could happen. Now also in buses, what we also have to bring to the attention of the viewer, that we have the passenger safety, because you have cameras in the buses, you have GPS on the buses, the bus will transport information back to the monitoring station.
The bus itself will be transporting data, or transferring data.
Yes.
Wow.
School buses everywhere, they send at least the route where they are right now, so you know within 2-3 minutes the location of the bus, because there's also always delay in the network, as you know, and there's also delay of the bus. So we can have prediction of a minute ago or 2 minutes ago where the bus will physically exist. And also when the buses, especially school buses, when they go back to the garage, they have to download all the recording from the 6 cameras in the bus. There is a law which require each school bus to have at least 6 cameras. And this we use it because of the kids and the students and We want to try to manage harassment and other stuff.
Yes.
So it's the same for sharing rides as well. Right now in Egypt, there's lots of requests to have.
We have this technology now.
Yeah, you have it in a private ride sharing applications. You have this technology right now. They have recording inside the vehicles, and they have the location, even for delivery. If you request a specific food or a specific meal from a specific application, you will be able to track the food coming to you. So this technology exists. Now, when you move to 5G, to smart cities, you will find this technology is sustainable, is robust. It will respond to you. It will not be just, oh yeah, it's a delay because the network is slow.
Yes.
No, in smart cities, this technology will send you the information.
It has the infrastructure.
Because it has the infrastructure. And this is why it was a very key matching the Vision 2030 with the concept of building these smart cities. I know because they are infrastructure, people are not used to it. They don't really give attention because it's hidden in the platform. But this is what this will do. If you walk around the new capital, you will find lots of signages. Maybe not all of them are working because it's not fully populated yet. But in the government part, there are lots of signages. It will tell you there are delays and there are issues in some areas, some intersections. Use left instead of right because there is, you'll be. So this kind of messages, I watched it myself when I went there for a couple of experiments or a couple of trips for work related. So it's a way to send the information back to the passengers. So basically people in the ground, they can get more information.
Yes, and finally, Doctor, what about, as we are in the months of the summer season, how can we be using the artificial intelligence to be predicting the demand for electricity and for energy?
Basically, if you count how many people coming to different areas and different buildings and different locations in the building, you can assume the amount, or you can compute the amount of energy needed, for example, for a cooling system or for air conditioning. And we have such a thing, by the way, in different malls right now. And if you go to different places in different universities right now, if you go to a place, you find there is a dimming light, and once someone will be inside, the light will be increasing. So having this on the city itself, it's one of the ways to save energy and basically drive the resources where people need it.
Yes, Dr. Wael Badawy, the Professor of Artificial Intelligence and Computer Engineering. Thank you very much for being with us tonight.
Thank you, I appreciate it.